Okay, especially when it comes to, we'll be looking at hydrocarbons, a very interesting topic in chemistry, though some students see it as a very, very difficult topic, especially when it comes to naming of compounds. Hydrocarbons are very, very easy to work with. Now, the first thing is, what are hydrocarbons? Do you have anything about hydrocarbons? What are hydrocarbons? Okay, are you there?
Yes, sir.
Okay, so what do you understand by hydrocarbon?
Hydrocarbon is a compound of hydrogen and carbon only.
Now, hydrocarbons are compounds that contain just hydrogen and carbon atoms only, element only, atoms only. Now, hydrocarbons, please need to write that, are compounds that contain both hydrogen and carbon atoms only. In fact, the word only is meant to be there. That word only, very, very instructive, should be there. An example of such is if you have something like this, C, if you have something like this, H, this is H, we have something, okay, if we have something like this and then we have another one, and you have something like this, we now ask you to identify which one is an hydrocarbon. Which one is an hydrocarbon? Is it A or B or both of them? Which one is an hydrocarbon? Or is it a hydrocarbon? A. Now, we choose A because we said hydrocarbons are compounds that contain just hydrogen and carbon. This contains carbon and hydrogen. This contains oxygen. So it is not an hydrocarbon. It's not a hydrocarbon anymore. This is something else. It could be an organic compound because we're talking about organic chemistry. We're talking about organic chemistry. Hydrocarbon falls under organic chemistry, but this can be an organic compound, but it is not what we call hydrocarbons. It is not hydrocarbons. So it's very instructive for us to draw that boundary that hydrocarbons, they contain just carbon and hydrogen atom only. Very, very instructive. Okay, another thing we should know is that hydrocarbons are classified into two groups. Number one, we have the saturated. Please, you need to write that. Hydrocarbons are classified into two groups, namely, we have the saturated and the unsaturated hydrocarbon. We have the saturated hydrocarbon and we have the unsaturated hydrocarbon. Now, the saturated hydrocarbons, I said we have a saturated. Okay, we have the saturated and the unsaturated hydrocarbon. Now, saturated hydrocarbon are also called alkanes. They're also called alkanes, and they have a formula of CN H2N plus 2. Now, these are for saturated hydrocarbons. And the other one, unsaturated hydrocarbon, we can also call them alkenes. They are alkenes and alkynes. We have alkenes and alkynes. The formula for this one is CN H2N, and this one, the alkyne is CN H2N minus 2. Okay. Sorry. Now, these are unsaturated hydrocarbon. Now, the question now is, why do we call one part saturated? And why do we call the other part unsaturated? Very, very important. Saturated hydrocarbons, this is how we know they are saturated hydrocarbon. Look at this. I didn't erase this because I was going to use this to explain something. Carbon normally have 4 hydrogen atoms bonded to it. You know, carbon is 2, 4, right? Isn't it?
Yes, sir.
Okay. Now, with an atomic number 6. Okay. Now, if it has an atomic number of 6, it's going to have 2. For it to be, that's 2,4. That means carbon would need, for why we call it saturated is that when it goes into covalent bonding, carbon is going to have, it's going to need 4 hydrogen atom. It's going to need 4 hydrogen atom for it to be saturated. And that's why on one carbon atom, we have 1 bond of hydrogen. When it goes into its covalent bond with it, another bond of hydrogen, another bond of hydrogen for it to be properly filled up, another bond of hydrogen. I think this shape is tetrahedral. That's methane. Is tetrahedral in shape. Now, but why do we call the others unsaturated? You see, the other one I drew, you're going to be seeing something like this, C, C, C. Now, this comma, this double stroke makes it unsaturated because instead of, remember I told you each carbon atom must be filled up with 4 hydrogen bonds, must be bonded to 4 hydrogen atoms. Now, this carbon, please note this is very instructive because this is going to help us when we come to naming and how to draw the formula. This is what will help us. Now look at this. How many bonds are here already? How many bonds are here already? This one. How many bonds are here already? 2. Okay. Now that means how many bonds do we have more to fix into carbon? How many bonds do we have more to fix into carbon?
2.
Or 2 more. So that means we have 1, 2, 3, 4. That means you will be having your hydrogen here. That means you won't have any other hydrogen on top because you count them 1, 2, 3, 4. The same thing happens to this. 1, 2, 3, 4. This is what makes, if you understand this concept very well, it's going to help you know how to form compounds on your own. This is what makes it unsaturated. Why it is unsaturated? Because it is not filled up. The one that is meant to be here, combined with the one that is meant to be here, they came together to form a covalent bond here. And that bond, remember, covalent bond has to do with sharing of electrons. Why electrovalent is transfer of electrons. So because they share electrons, carbon, the bond that was meant to be here, to make this saturated, they came here to form another double bond. So that's why we call this alkane. Alkanes are single bond. These are alkanes, they are single bond, While these are alkenes, they are double bond. But when we come to alkynes are triple bond. 1, 2, 3. They are triple bond. So we already have 1, 2, 3. So we just have one hydrogen fixed to it. One hydrogen fixed to it. Do you understand that?
Yes, sir.
Okay. Now, that was just a brief summary of everything that has to do with saturated, why we call that saturated, and why it's the other part, it's unsaturated. The next one, it's hydrocarbon. Please write this, very instructive. Hydrocarbons can be classified into number 1, aliphatic, and number 2, aromatic. Hydrocarbons can be classified into aliphatic compounds and aromatic compounds. Aliphatic compounds and aromatic compounds. Now, when we talk about aliphatic compounds, have you written that?
Can you say aromatic?
Aliphatic compound, number 1, and number 2, aromatic compound. Okay, when we talk about aliphatic compounds can also be classified again. Aliphatic compound can also be classified into, let's see if I could get that. Wow, I've coming. I think I have to just delete some of this. Okay, I will just have to delete this. Okay, let's come back to it now. Now, aliphatic compounds can also be classified into a cyclic, and cyclic. Cyclic. Now, when we talk about a cyclic as straight chain hydrocarbon. These are an example, making it like they are so straight. They are straight chain. We can have them as C. You can have them as C. You have them so long. C, C, C. Then you have your hydrogen, 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 uh, hydrogen. Okay, now the question now is, how do we name this? This is an example of a cyclic. This is an example of a cyclic hydrocarbon. Now, this is how many carbon atoms do we have here? We have 1, 2, 3, 4, 5. So the name of this one is pentane. Don't worry, we'll come to naming very soon. Now, this pentane can also be written as in another form. Now, what is a cyclic? A cyclic is actually a branch chain. A cyclic at this point, it could be a branch chain. It could be a branch chain of cyclic hydrocarbon. So, sorry, where this? Now I could decide to write this like this: 3, 4, and I have my C, and I have my C here, Okay. I have my C here. So that means, remember, all these parts that I didn't put anything, they are hydrogen. I hope you understand that.
Yes, sir.
Okay. Now, this could be a cyclic, or I could have something like cyclo. Now, the name of this one is called 2-methyl 2-methyl butane. Now, or I could have something like this. I could have something like this: 1, 2, 3, 4. 1, 2, 3. 1, 2. I could have 1, 2, 3, 4. 1, 2, 3, 4. Now, this is called cyclo. 1, 2, 3, 4. Hexane. Now, this is an example of cyclic. Now, a cyclic are actually the straight chain compounds or hydrocarbon, and cyclic could be the branch chain, or they could be in a cyclic form, like a cyclic form. I don't want to say a ring form because we are coming to that aspect. A cyclic form. So this is an example of a cyclic pentane, a straight chain. They have no branch chain, but cyclic a branch chain, or we could have them as a cycle form. Like we call, when they are cycle form, we call them cyclo. Cyclo will be added to the name, then count the number of carbon atoms, and that gives us hexane. I believe you understand that point.
Yes, sir.
Okay. Now, the next thing we would want to understand is, we've talked about aliphatic. The next thing we'll be talking about is the aromatic. Aromatic, the aromatic compounds, they are derivative of a compound named benzene. They are derivative of a compound named benzene. Benzene. Okay. They are derivative of a compound named benzene. So let me show you that. Okay. These are examples. Okay, let's clear this quickly. Now, the derivative of a compound called benzene. This is an example of benzene. Oh no. Sometimes you can see it like this, then you see it like this, then you see it like this, or you can see it like this. So I'm showing you there are 3 different ways to draw it, so that when you see it, you would not be confused. But it's very instructive that you keep to the rules of the game when drawing it. You can also see it like this, then in round form. Now, this shows that the structures they are rotating. The ring structures are rotating. They could rotate to these aspects. So if you check some textbooks, you might see benzyl being drawn like this. Remember, everything here is just C, 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 but the ring structures are rotating. That's why you can see benzene drawn like this. You could see it drawn like this. You could also see it drawn like this. So they are derivative. These are aromatic structures. They are the ring-like structures, and derivative of that. Now we have the benzyl as a whole. It's the aromatic compounds. They are something different. We have compounds of benzene like this, OH. We have other ones having CH, CH3, and we also have a, come in please. Okay, we come in, I'm trying to check out for something. I'm coming. Where is this stuff? Okay, we have the OH, we have the CH3. So we have compounds of the other compounds of benzene. We have them as toluene, methylbenzene, and that is the aromatic structure. So number one, hydrocarbons can be divided classified as saturated and unsaturated compounds, hydrocarbons. Benzene is actually unsaturated. Now, hydrocarbons can also be classified as aliphatic. Aliphatics we have the cyclic, the straight chain, and the cyclic, which are in circle forms. And we have the cyclic, the aromatic compounds, which are derivative of the word benzyl. When we come to benzyl as a topic, then we can delve deeper into benzene. Now, we want to see, I think the next thing should be how to name compounds. How to name compounds is very instructive because we'll be learning, we should be learning. Okay, sorry, were you guys able to name compounds? When they taught you chemistry, when they gave you the notes, was there anything of such? Are you there? Hello?
Sabi, what did you say?
Okay, I said, were you people, was there anything given in that you learn how to name compounds?
No.
Can you give me a rundown of what you guys talked in hydrocarbons so that I know how far you guys have gone?
He gave us petroleum and natural gas. It was the refining process of petroleum,
Okay.
products of producing petroleum refining, cracking and reforming,
Okay.
um,
Okay.
octane numbering,
Okay, I
and
think I know
petrochemicals.
now. Okay, Tams, I'm just going to do little introduction into naming. I guess you're meant to do that more in SS2. You're meant to do that more in SS2. So let's just go. Let's see how we can name compounds. I think it will be an advantage for you also. It will be a good advantage. So let's see how compounds can be named. Very, very important. All right. Let's come back to the screen. Naming of compounds. Naming of compound. I'll just do an introduction because I'll be giving you simple compounds to name, not something difficult. Now, Okay, when we talk about naming of compounds, the first thing we should understand, there are some rules to follow. But before then, we know for the alkane family, I gave you the formula as CnH2n plus 2. Okay, now if n is 1, what would be the formula? What would be the formula if n is 1? What would be the formula if n is 1?
CH4.
Okay, CH4. And if n is 2, that becomes what?
C2H6.
Okay, C2H6. If n is 3, let's do to 5.
C3H8.
Okay, to 4.
C4H10.
Okay, C4H10, and the last one, let's stop there. 5.
C5H12.
Okay, C5H12. Now, look at this word ANE. The word ANE. Oh no, that was not too dark. Okay, let's use a black one. ANE. You will see us always using that here. We're going to be using that here a lot because we're talking about the alkene family. That the ANE is more or less like the surname. Good. Let's use that word. I like that word. The surname attached to every compound in the alkane family, just like your name is Muna, and then your surname is Fabian, right?
No.
Oh, sorry. Okay, let's use somebody else. I really thought that was a surname. Okay, let's use somebody's name was John Daniel. John Daniel. Okay, everybody in the family, if they give birth to Deborah, she's going to be Deborah Daniel. If you give birth to another person, Rita, is going to be Rita Daniel. The same thing also, this ANE is a surname. Now, this first one, Myth, because it's having one, we'll call it Methane. ANE, methane. Actually, the dash is not meant to be there. I'm just using that for you. You just write it as if one word. The dash is not meant to be there. Now, the next one, C2H6, is actually ethane. Ethane. Okay, the next one is propane. Okay, so you're seeing their surname affecting them there. The next one is butane. Sorry, butane. And the next one is pentane. All right, now that's an example of how their surnames are affecting them there. Okay, we have the ethane, methane, propane, butane, and pentane. Now, if we understand that this is what it is, the next thing we should learn to do is let's draw the structural formula. Now, if they ask you what is the molecular formula of alkane, this is what you call molecular formula, MF. Molecular formula. Okay, they might not ask you, okay, we want the structural formula. Structural formula has to do with the structure of how this looks like. Okay, now the structure of methane is, remember, is 1C. We have 4 hydrogen attached to it, and that becomes H, H, H. All right, now I have drawn methane for you. I want you to draw ethane, propane, butane, and pentane. If you can annotate them, no problem. Correct. Okay, okay, correct. All right. This is ethane, and this is propane. So you can draw the others in your notes. You can draw butane and pentane in your notes. Are you done now?
Yes, sir.
All right. Now let's continue. The next thing is now that we've established that this is methane and this is propane and ethane, the next thing we should learn to do is I'll be giving now. It's this the last thing I want you to know. It's that's for this level now. Is something called methyl. Okay, something called functional group. Functional group. Functional group. Functional groups are actually groups added to organic compounds to ease the naming of such compounds. Functional groups, like I said, are groups or compounds added to most hydrocarbons or most organic compounds to ease the naming of such compounds. Examples of functional group, we have them as the methyl. We have them as the methyl group. We could also have hydroxide could also be a functional group. Uh, but we'll bother ourselves more with methyl, the methyl group. The methyl group has a molecular formula of CnH2n plus 1. The methyl group, you have a formula of CnH2n plus 1. So the question now is coming. Let's okay. The question now is when n is 1, we have it as CH3. Now remember, methyl, it becomes METHYL. This is a methyl. Now that's when it is 2, it becomes C2H5, and this is ethyl. So we have the methyl group, or the sorry, I'm sorry, I just made a mistake. This is not, the main group is not called methyl. The main group is called the alkyl group. Sorry for that. It's actually the alkyl group. It's actually the alkyl group. So when N is 1, it is called methyl group. When it is 2, it is called the ethyl group. The ethyl group. Okay. Now, I'm going to give you, we're going to start with, let's start with this little formula. Let's start with this. We're going to have 1, 2, 3, 4, 5. Now, I have the first one here. I'm not going to be putting my dash because I assume now you should know that hydrogen should be what will be there. So, but please make sure you do that in yours. Okay, we're going to be having these, 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 these. Okay, Now, let's look at the laws or the rules of naming compounds. The rules of naming hydrocarbons. Rules of naming hydrocarbons, because they are not the same rules we use in naming inorganic compounds. They are not the same rules. They are quite different. They are quite different. So let's look at the rules for naming organic compound. Number one, identify the parent hydrocarbon. Identify the parent hydrocarbon. So identify the parent hydrocarbon. So the question I would ask you now is, what is the parent hydrocarbon here? The parent hydrocarbon is actually the straight one at this point. What's the straight? Look at this straight hydrocarbon, this straight chain, this straight one, the straight one. What is it called? What is it called?
Pentene.
Sorry?
Pentene.
Pentene. Good. Write pentene. Just write it somewhere. Now, the first rule, we have identified the parent hydrocarbon. The second one, it's number two. Identify the functional groups attached to the parent chain. Identify the functional group attached to the parent chain. Identify the functional group attached to the parent chain. Okay, so what's the functional group attached to this parent chain? What functional group is it?
Methane.
Sorry?
Methane.
Sorry, what did you call it?
Methane.
Please spell it.
Methane.
No, methane. No, not methane. No. Look at. Is it this thing you're trying to call this thing here?
Yes.
Methyl or methyl?
Methyl.
Okay, you see that is exactly what was attached to this, right?
Yes.
That's the only functional group that was attached. So this is a functional group that was attached to it. So we call it methyl group. Okay, so that's the functional group. We identify it. Okay, that's the first one. Number two. Now, number three is number three law. It's a rule. It's number three rule. I'm trying to see how to place it. Is from the right. I mean, not really from the right. It's identify the position. That's the word I was looking for. Identify the position of which it is closer to the carbon atom. Identify the positioning of which the functional group is attached to the carbon atom. Identify the position from which it is attached to the carbon atom. Now, it could be from the right, it could also be from the left. But we are looking at the closest. Oh, please write the word. Identify the nearest position. Please, that put that word nearest is important. or the closest position. Very, very important to us. The closest position by which the functional group is attached to the methyl group. Identify the closest position by which it is attached to the methyl group. So I want to ask you to check comprehend on the, or to check comprehension. What is the closest position by which this methyl group is attached to the carbon atom? What is the closest position? Let me help you out. Just a clue so that you can understand it. If I start counting from here, 2, 3, 4, it will be 5, yeah? But if I count from here, 1, 2, 3, 4, 5. So what is the closest position by which this methyl group is attached to a carbon atom?
2.
2, correct. If we count from this, from my left-hand side, it will be 4. But we'll be violating the law. But if we count from the right-hand side, as I said, it could be either from the right, it could be to the left or from the left. So then we can say that 2 is the closest to us. 2 is the closest to us. Now, at your level now, I'm going to stop here. I'm going to stop the rules from here because I doubt you won't be giving complex compounds. Now, if you have complex compounds, the rules continue because it would not, okay, number 4, let me give you the last one. Number 4 has to do with, if you check the way I wrote, I don't know if you still have your notes, if you can still remember how I wrote 2-methyl, what was that thing I called? 2-methyl what? I think I wrote it down somewhere. One of the examples I gave.
2-methyl butane.
Okay, how did I write it? I need you to tell me, how did I write it?
2-methyl.
Good. I think that's good. I thank God you wrote that dash. That was, I was actually obeying a rule. Now, I was actually obeying a rule. Okay. Now, see what I'm going to do. I'm going to add another CH3 here so that we'll have 2 CH3. So it will make you understand the essence of that rule. I'm going to add 1 CH3 here. Or if I don't add the CH3 here, I could also put C. I could also put C dash dash dash. Okay. Now, one of the rules I want us to notice is this. Now, look at it, has changed the name. I've already changed the name of this compound. This compound is no more, because if we're to continue, this compound was 2-methyl pentane, 2-methyl pentane, but now I have changed the name. It is no more 2-methyl pentane. Let's identify. Now, this is 2. Just know that if you started counting from your right-hand side, you will follow the counting process like that. Now, this will no more be 2. This will not just be 2. This will be 2, what? 2,4. 2,4 now, right?
Yes.
Okay, you understand that. Now, the 4th rule. Let's come to the 4th rule because this one has given us something different now. Where there are the same functional group, where there are the same functional group, we use the prefixes such as di, tri, tetra. Have you written that?
Yes, sir.
Okay. We use the prefixes such as di, which is for 2, tri, which is for 3, and tetra, which is for 4. Okay, so that means this will be, that's the fourth row. Number 4, this will be dimethyl, right? Isn't it? Dimethyl, isn't it? Hello?
Sir, sir.
You said what?
I didn't hear you.
Okay, I said this number 4, you saw what I wrote number 4 below, that this will be where there are where there are more than one methyl group, we'll call them, this becomes dimethyl, isn't it?
Yes, sir.
Okay, number 5 rule, the last one for today. This is not all. Remember, I told you for your level now, we'll be using this. But when we come higher, because we have organic compounds where we have so many functional groups. Many functional groups. So, and we must learn how to name it. Okay, number 5. Number 5 is use commas to separate numbers. Use commas to separate numbers, and use dash to separate between numbers and alphabet. Use commas to separate numbers, and use dash to separate between numbers and alphabet. Okay, have you written that? Hello? Are you there?
Yes, sir.
All right. Okay. Now, give me the name of this compound now, following a rule.
Two comma four dash dimethyl pentane.
Please say that again. I didn't get that.
2,4 dash dimethyl pentane.
Correct. So, following all this, that was actually 2,4 dimethyl pentane. Right. That looks quite big and interesting. Okay. I think I have a little question here. Very, very good. Okay. Quickly, I have to quickly note this so that you don't get used to this part. When we say identify the straight chain or the parent chain, it could be, okay, an example is this. Let's use a very long one. Let me stay, okay, let's go beyond the boundary of 5. It could be this. I need you to know. It could be this. When I say identify the longest chain, please, instead of writing identify the straight chain, please write identify the longest chain. I think that's better. Number one rule, identify the longest chain. I think is better. The longest is better because actually the longest for us could be one. Sorry, let me change that. The longest for us could be 1, 2, 3, 4, 5. It could be from here 1, 2, 3, 4, 5. Why this is on the second carbon atom? This could be like a functional group. So it is not necessarily that it must be the first, the longest one. The straight chain, like we just count straight like an express route. It could be, remember when we talked about aliphatic? Aliphatic could either be the straight or this branched one. So it could be this one. It could also be the one down. So I don't want you to grow up with that knowledge that, okay, it must always be this long one. This is what I was told, and this is what I will ever be told. I was told this when I was when I was in secondary school, but when I got to the university, I got to realize that even from our textbooks, the normal Ababio textbook, I started seeing that most of them, when it comes to naming, most of them were not just these ones. They were not just the straight chain. They were also, some of them were the longest chain. That's why I said it's not necessarily a straight chain. The first thing is to identify the longest chain. If I take this 1, 2, 3, 4, 5, let's assume I blinded this one. It's still going to be 5. It's still going to give me 5, which is pentane as my parent's chain. Why, if I put these 2, it's going to give me 2-methylpentane. It's still the same thing. So I wanted you to come to that understanding. Now, I'm going to give you now, allow you to name this. I'm going to allow you to name this compound I want to give you now. Okay, please name this compound.
Said it says this dash that you put in between these two C's.
Sorry, what did you say?
Dash you put in between these two C's.
You should put what?
Like this dash. We meant to be there because there's even one here.
Oh, actually, okay, this dash. No, H is there, please. H is in all of them, hydrogen. So how do you name it now? How do you name it now? How do you name it now?
Two comma 2,3 dash trimethylpentane.
Awesome. Correct. 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 That's a beautiful one. Hey, that's a very beautiful one. 2,2,3 dash trimethylpentane. Good. 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 2,2,3 dash dimethyl pentane. All right. But look at this. I want you to notice this. You're really doing well in this. This is good. Now the next thing is look at. Do you know I can also write this thing like this? Watch this, because if you don't understand this other part, you'll be surprised why. Because I want to give you classwork, and I'm gonna scatter it. Please, why is that lady disturbing you now? Tell her if I catch her. Is not that one? Is she the one in? Is she the one in Brereton?
All of them.
One of them. Tell her if I catch her.
She's a liar.
Are you serious? If I catch her.
The youngest one, she's asking me questions.
That youngest one that disturbed us the other day. Now she's coming again. It's all right. Tell her I'm marking her face. In fact, let her change her school and come to Brereton. Let me catch her there. It's all right. Okay. Let's see. Look at this. I'm gonna take this one by one now. Look at the way I'll do this. Do you know that this first one I can take it as C? I can take it like this: CH3. I'm taking this first part. This first part. The second part, I'm going to take it as C bracket. Bracket means that they are branch chains. They are branch chains. And I'm going to put CH3 CH3. Are you seeing this? I would also put this on as CH into bracket CH3, and I could also put CH3. Imagine I gave you something like this. Come, won't you be scared?
Yes, sir.
But definitely, this is what you just did now. This is exactly what you just did now. It's the same thing. So I could give you this. They could give you a question like this, and they ask you to name it. To name this compound, you have to draw the structural formula, and you have to name it. So your ability to combine all these things, your ability to combine all of them, makes you have a knowledge of what you've just done. I'm going to give you two more simple questions before remember, I'm still within the confines of what you should know. I've not gone to the advanced ones part. That should be in your SS2. But let's just stay within the boundaries of these ones, and let's see some questions. Are you done writing these things?
Yes, sir.
Okay. Let me get a question for you. The question is number one. You give me the name of this compound. Okay, these are questions I want you to try them out. All right. Please say that again.
2,3,3,3 dash tetramethyl hexene.
Sorry, say that again. 2,3,3,
3.
3 again. Are you sure?
Sorry, 4.
Hey, 4,
Dash tetramethyl
tetra, methyl. Okay.
hexene.
How did you know that was hexene?
Because it's 6.
Eh?
Because it's 6.
I didn't tell you that, so how did you know?
I guess
Sorry?
it gave me 6 carbon.
Yeah, I did a 6 carbon. We never did anything 6. So how did you know?
And 6 is hexagon. So
It's hexagon.
your name, so hex.
Okay. I will believe that aspect now. You said you know 6 as hexagon. Okay. That's good. No problem. I agree to that. Okay. Have you done number 2?
No.
Okay, no problem. Try number 2 then.
Thing.
Again, the second one is what?
2,2 dash dimethyl propane.
2,2 dimethyl butane propane. Okay. All right. Let's go back to number 3 then. I think there's I just discovered something here. There's a mistake here. This was meant to be 3. Did you get that?
Yes, sir.
Sorry, I didn't get that.
1,1 dash dimethyl pentane.
You said 1,1 dimethyl what? Dimethyl what?
Pentane. Pentane.
Pentane. Okay, let's let's go through let's go through that. This one. This one was correct. So I would need to delete this so I can work with that space. All right, the other one, the other one, the other one is C. We have four of them attached to this. So we have CH3 here. We have CH3 here. We have CH3 here. We had CH3 here. The straight one is 1, 2, 3. So we have 2,2 dimethyl propane. So this was correct. Got that one. Now the next one, we had C. We had CH3. We had CH3. We also had CH3. CH. We also had CH3. With the next one, HH. With another one, HH. With another one, HH. Remember, this C here is also the same thing as C, 1, 2, 3. So that means what is the name now? That means you failed this. What's the name of this now? What's the name now?
1,1,1 dash
No,
dimethyl.
no, this one. That's not the name. What's the name now? What's the name?
Two comma two dimethyl
Dimethyl what?
pentane.
This is the way. This is the way I wrote something we have done before. I wrote it on that form now. Now you got more confused. You see now, so it's something we've done before. but it was now more confusing because of the way I arranged it. So you now see the trick behind the hydrocarbons. That one of the things is you should know how to arrange it. Because if you don't know how to arrange it, you'll be surprised that everything they've given you is what they've given you before, but it looks so confusing. So confusing. Yeah, how I even knew this was not correct was when I saw 1-1. I knew that wow, something is wrong. So I guess we need to open it up. It's if you know the trick behind this, it's actually a lot trickier. Very, very tricky. So, but if you know the trick behind all this, um, you'll find it very, very something very easy to do. Okay, okay. Have you written that?
Yes.
Okay. Um, let me see, let me see, let me see, let me see. Okay. Let me quickly give you your assignment. Oh, I'll need to give you some assignments on this. Um, 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 coming. Oh my God, where is this thing? Let me get it up. Oh, wow. I have some questions here. Very interesting question. Okay, I think, let me see if I could send this question. So I might just need to, oh Jesus, where is this? Oh, okay. I think I'll quickly expose you to something because, okay, before I go into that, let's do this. Your assignment, number one, write, draw the structural formula of the following compounds. Draw the structural formula of the following compounds. Oh, there's something I didn't give the instrument, but number one, number one, 2233, 2233 dimethyl dimethyl heptane. dimethyl heptane. Number 2, 2-hydroxyl butane. 2-hydroxybutane. Number 3, should be Sorry, did I call this thing dye? Jesus, this is wrong. That was wrong, isn't it? Okay, have you gotten this?
Yes, sir.
Okay, let's pray now. All right, Father, we thank you for today. Thank you for how far you've helped us. Thank you for your message. Thank you for your love. We pray for everything we've learned. We thank you for everything. Blessed be your name. Grant your daughter more wisdom, understanding in the name of Jesus. In Jesus' name, I pray.
Amen.
Okay, so work with them. I'll be expecting to hear from you.
Okay.
All right, have a wonderful time.